Hi folks, this is another video for the solar energy series. A friend of mine recently let me make a video of his solar thermal or solar hot water system which he installed in his house. So I packaged it up into this video for you. This system is manufactured by Enerworks. It's installed in Ottawa, Ontario, Canada, where the temperature in winter stays below freezing for 3 or 4 months of the year, so cold weather is an issue. Just like with the off-grid solar power video, I'll start with a diagram. Otherwise you'll be completely lost by some of the complex piping. These are the solar collectors, or panels, which are installed on the roof. They're often referred to as flat plate collectors, because they're flat plates. They consist of a tempered glass glazing in front, followed by a small air gap, and then the absorber, which is a sheet of thin metal with a dark coating on it. Attached to the back of the metal is a serpentine length of copper pipe. The sides and back are insulated. A pipe coming from the basement is connected to one end of the serpentine pipe, and another pipe is connected to the other end. Also in the basement is a pump, which pumps a fluid through the pipe. There's also a heat exchanger, which I'll talk about shortly. The pipe doesn't contain just water, since the water in any part of the pipe that's exposed outdoors would freeze, turn to ice, and then crack the pipe. Remember, this is a cold climate. Instead, it contains a 50-50 mix of antifreeze and water. The antifreeze is food-grade propylene glycol. The way it works is that photons from the sun are turned into heat by the dark coating of the absorber. Much of this heat is transferred to the copper pipe and then to the propylene glycol water mix in the pipe. The pump circulates the fluid through the pipe in a closed loop. For that reason, this is called a closed loop system. And that's how the heat is carried from the collectors down to the basement, by circulating the heated fluid. So here are the two Enerworks panels up on the roof. Down there you can see where the pipes go. There's the cold propylene glycol and water mix going in, and then the hot return, as well as a temperature sensor wire. So you can see there's actually two panels. There's a flashing on top there in the middle, just to cover up and protect the pipes and the wire. And the way it works is the hot propylene glycol, the cold propylene glycol water would come in one side, snake up through the copper pipes, and then cross over to the other panel, snake back down, and then go back as the hot. And the temperature sensor would be connected right in here near the hot output, just wedged in between the copper pipe and the absorber itself in the back. There it is up on the roof. You see the pipe snaking down. Here they are underneath that awning. And they just go into the wall right there. The other half of the system is all this. The tank on the right is the old natural gas heated tank. The tank on the left is a solar heated tank. This half of the system contains the water used for tap water, showers, and dish and clothes washing. So here we are in the basement with the two tanks. This one right here is the solar tank, and that's the regular tank. And if we look back here, we can see where those two pipes that came from the roof are. And they just follow behind down here. And then this is where they split. So one of them goes right here, and one of them, the other one, it goes up to this temperature gauge right here, and snakes back down there and into this. This right here is called the energy pack. I'll just open it up for you. There it is, opened up. Now the top pipe here that I was pointing to, with this temperature sensor gauge right here, and an expansion tank, that's the hot in. And that goes into the top of the heat exchanger. So this piece right here, all this chevron shaped thing, is the heat exchanger. And so the hot propylene glycol water goes into here, into the heat exchanger, then down through the heat exchanger, and then returns as the cold output right here, past this temperature gauge, and then back to the roof. One other thing to note is that this is the pump right here, which, as it says, it's hot, and that's true. And that's the pump that's just pumping the fluid back up to the roof. There are two cases to look at. The first is what happens when no water is being used, no tap is open. This is when the solar heating takes place. In that case, the water in the heat exchanger has heat transferred to it by the hot propylene glycol and water mix. No fluid is transferred, just heat. Hot water rises. This hot water flows into the solar tank. Since hot water has risen from the area of the heat exchanger, cold water is pulled in from the bottom of the solar tank to replace it. This process is called thermal siphoning and is how the water in the solar tank is heated. Now, when you're not using the taps, when no tap is open, the loop is actually fairly simple. What happens is you have and assuming that the heat exchanger is hot, in other words, you actually have sun out right now. In that case, the heat exchanger right here, one side is the propylene glycol that's circulating out to the roof, but then the other side of the heat exchanger is the tap water. And that's a simple loop right here. Now what happens is the heat from the propylene glycol gets transferred to the tap water, and that tap water rises because hot water rises naturally. It's called thermal siphoning. Rises up through this pipe right here and down into the tank. Now how does it get down into the tank? Well, if hot water is rising up, then that nature abhors a vacuum, so it's going to pull in cold water, and that cold water is going to be pulled in through this pipe back here, which is connected to the bottom of the tank, and it just goes into the bottom of the tank right in here. There we go. And that cold water that's being pulled in is just coming from the tank. The second case is what happens when you open a tap somewhere. The water in the system is under pressure, around 54 pounds per square inch. This pressure is provided by the city. When you open a tap, that's like making a hole in the system, and water flows out of the tap. That water is pulled from the natural gas heated tank, which gets its water from the solar tank. And that's when the hot solar heated water goes from one tank to the other. Meanwhile, cold city water is pulled into the bottom of the solar tank through the Enerworks heat exchanger. Why through the heat exchanger? Mainly so that any particulates in the heat exchanger will be cleaned out. These will be deposited in the bottom of the solar tank and are removed by opening a tap at the bottom of the tank as needed. That's an Enerworks feature. Oh, one last thing in case you notice that the water flows in two different directions through the heat exchanger depending on which of the cases is happening. There's a special Enerworks patented backflow valve here which takes care of this. Now if we open the tap somewhere, well, tap water in the whole city is under pressure. So if you have the tap closed, then it's under pressure. But once you open the tap, then you make a hole in that whole system, which reduces the pressure. So now we go to our natural gas tank here, and this is the pipe that's going to the taps. So when you open a tap, you're creating a hole in this pipe basically. So water's gonna, because of the pressure, the water's gonna fly out into the tap. So it's gonna be pulled out of this tank. And where it's going to come from is in the tank where we have solar water that's heated or natural gas heated water. And this is the pipe that goes to the solar tank right here. So it's going to be pulling that water out of the solar tank and into the natural gas tank and then up to the taps. So if you never use your tap, then you're never going to be pulling water, hot water from the solar tank. And in fact, that's the only time the solar heated water will go into this natural gas tank is when you open the tap. So again, it pulls from the solar tank, which has the hot water in it. So when you pull from the solar tank, naturally water will be going up from the tank, so it has to go back into the tank somewhere. Now normally that would be city water going into the bottom of the tank, but in the case of Enerworks, they do something special. Here's the pipe that's hooked up to the bottom of the tank, and that goes to the bottom of the heat exchanger, and then from the heat exchanger, that pipe goes up, up, and up, and up, and back here, and up, and to the city pipes. That's the cold water for the city right there. Well, there's a lot more I can talk about, but that's probably enough to absorb for one video. So I made another video with details about the expansion tanks, temperature sensors, controllers, and so on. Anyway, thanks for watching. Also have a look at my YouTube channel, rimstar.org, for more solar-related videos. You can find a lot more of them in the Renewable Energy playlist. Be sure and check out the other videos in this solar energy series, including Part 1 about nuclear fusion in the sun, and Part 2, which is a tour of an off-grid solar power system, as well as Part 4, which includes the additional details about this solar thermal installation. And at the very least, be sure to subscribe if you like these videos. See you soon!